Hello, welcome back. Problem from Parabola. Find the locus of point of intersection of tangents to the parabola y square is equal to 4x. This is my parabola, which are inclined at an angle theta to each other. Means we have a three problem associated with this parabola. What it says, find the locus of point of intersection of tangents to the parabola, which means this tangent which are inclined to an angle theta to each other. That is the first one which we need to find. Second says which intercept, what is which means this tangent intercept constant length c on the tangent at the vertex. And third one, it says these tangents are such that area of ABR is constant C, where A and B are a point of intersection of the tangent with the y-axis and R is a point of intersection of tangents. Okay, let me draw a parabola, then these questions will be clear. Then I'll take this question one by one and we'll find out the locus of the point of intersection. Okay, let's draw it first. Okay, drawing a parabola is a very difficult task here in paper, but I'll try my best. Here, yes, yeah, this is your parabola. Yeah, it's not that perfect, but it's fine for these questions. Now we have two tangents, right, across this parabola. According to the problem 1, the tangent would make angle theta. Okay, so first let me find out, let me draw a tangent to this parabola would be something like this, and another tangent would be somewhere from here, but both won't meet at x-axis. Just I need to take care of this. Okay, it will just touch and it will go away, right? Okay, then we have here this point is given as R, this point is given as A, this point is given as B. We have this parabola y square is equal to 4x, y square is equal to 4ax. Okay, these two are tangent. These two means this yellow one and this yellow one. This is T1 and this is T2. Okay, and the point of intersection of means this tangent at the point, let's assume AT1 to AT1 is square, I guess. AT1 is square to AT1. This is the point here. Here we have a point AT2 is square to AT2. Okay, these are 2 points. According to the first problem says that this yellow two tangents is inclined to an angle theta to each other. It means it's making angle theta over here, right? Okay, then what is the equations of these two tangents? T1 will be what? Y is equal to, y should be equal to what? Y is equal to mx plus c, or what? In general, if you have a y is equal to mx, y is equal to mx plus a by m square, right? It's something like that. Okay, then you will have here a by t1, I guess, x a by t1 into x plus some constant that I need to find out. Okay, there's a way to find out. Okay, I don't have much time to prove means what would be the tangent over here, but quickly if we can see we can find out dy by dx quickly. Sorry, let me draw it here. Let me try dy by dx should be equal to 2a by y. Okay, it means at 80 square and 281, what would be the dy by dx? Means m would be equal to 2a by 281. Okay, it means 1 by t1. Correct? You have means m is equal to 1 by t1, means y is equal to mx plus c, right? That is the equation, mx plus c. You have m equal to 1 by t1 into x plus c, and this line is passing through 81 square to 80. Just put 281 should be equal to 81 square by t1 plus c. Okay, this will get cancelled. 281 means 81. Okay, c will be equal to 81, means you put here 81, means y is equal to x by t1 plus 81. Okay, plus 81. This should be plus a t1. I'm sorry, this won't be a. Okay, why? It means this is the equation of this line t1, y is equal to x by t1. Similarly, for this tangent, you will have y equal to x by t2 plus at2. Okay, you got it? Means you have a here y is equal to mx plus c1, y is equal to mx plus c2. What is the m1 for this? 1 by t1. What is the m2 for this? M2 for second tangent, 1 by t2. What it says, angle between these two line is theta. It means tan theta. Tan theta is equal to what? Tan theta is equal to m2 minus m1 divided by 1 plus m1 m2. Okay, now you will put this value over here, means 1 by t1, 1 by t2, and we need to find, you don't forget that what we are trying to find out. We are trying to find out this one, hk, a relation between hk, because hk is the locus. You will have several kind of tangent, t1 dash, t2 dash, t3 double dash, t4 double dash, several kind of tangent. You will get at least something locus like this, means hk. We need to find the relation between hk, right? Once we'll get the relation between h and k in form of some constant, what we'll do, we'll replace h with x and replace k with y. You will get the equations. Okay, now what we will do here, we will put like tan theta is a constant, no problem. Here m2 means 1 by t2 minus 1 by t1 divided by 1 plus 1 by t1 t2. Okay, if you solve it further, what you will get, t1 minus t2 divided by t1 t2 plus 1. Okay, and that will be constant tan theta. Now we need to put t1 t2 values. How you will do that? t1 t2 are not constant. t1 is the gradient of capital T1 tangent, and t2 is the gradient of this capital T2 tangent, right? These two t1 t2 will vary according to this tangent, and we need to find the relation between h and k. What we will do, these two line, y is equal to x by t1 at1 and y is equal to x by at2 t2, these two equations are passing through h and k. Okay, if these two equations are passing through h and k, these two equations will satisfy with this value, hk value. Okay, then it means we have some relationship, right? What relationship we have here? We have k is equal to h by t1 plus a t1 and k is equal to h by t2 plus a t2. What we will do over here, we need to find out t1 minus t2. So how to find the t1 minus t2 here? This k will get cancelled, right? This k will get cancelled. Then what you will do over here, simply 0 is equal to h 1 by t1 minus 1 by t2 plus a t1 minus t2. Okay, then what you will get here, t1 t2 means h is equal to t1 t2. Okay, a t1 t2. And similarly you can find out the value of k, whatever means here, just you put h value over here, you will get some relationship. K should be equal to t1 t2 a t1 t2 by t1 plus a t1. Okay, this t1 t1 will get cancelled. You will get k by a equal to what? K by a should be equal to t1 plus t2. Means you got t1 plus t2 and you got t1 t2 value. What you will do over here, you just do square tan square theta. Actually I'm running out of time, let me do it as quickly as possible. T1 t2 plus 1. What you will do over here, just simply replace t1 minus t2 to t1 plus t2 square minus 4 t1 t2, right, and divided by, this is also square, divided by t1 t2 plus 1 square. Now you have all those value, you just put it, you will get the result. Okay, what you have, t1 t2 means h by a, t1 plus t2 means k by a, you have k by a square minus, this is h by a, right, this is h by a. Hope you understand this. Yeah, this is h by a. Now divided by t1 t2 means h by a plus 1 square, and that is equal to tan square theta. All things are constant, theta is constant, right? A is constant because your parabola is constant. Then you have a relation between k, h, right? You just replace k with x, h with y, you will get the locus of the intersection point of these two tangents. Okay, hope this first problem you understood. Okay, first problem was what? Find the locus of the point at intersection of tangent which are inclined at angle theta. This is solved. In next lecture I will solve this one. Hope see you soon.